Okay, I'm going to get started now. So I'd like to welcome everybody to our August webinar on UDP acceleration and as a replacement for FTP and its benefits. So I'll just start by a little bit of background. This is actually a webinar that kind of goes right back to our roots back in 2005, 2006 when we first launched FileCatalyst. So we usually do a lot of webinars on our advanced feature sets and that sort of thing, but this is really going to be the nuts and bolts, the very underlying transport and what our bread and butter is, and that's overcoming the whole problem with latency and packet loss on your network. So the agenda is going to go with a little bit of background about TCP. A lot of people feel or get the impression sometimes that we're saying that TCP is bad. UDP is much better, but that's certainly not the case. TCP without it, the internet wouldn't be what it is today. There is certainly limitations with regards to file transfer with TCP, but it's a great protocol for everything. Then we'll talk a little bit about UDP and how the acceleration within FileCatalyst works. I'll give you a bit of an overview of the speed comparisons between FileCatalyst versus any TCP-based protocols that you'd expect on, and the example I'll give is on a 45 megabit link, just to keep it realistic. I'm going to give a quick demo of FileCatalyst, and what I'll do is I'll show you FileZilla transferring a file across the network, and actually that demo is using a 100 megabit link, and then I'll show you FileCatalyst on the same link, and I'll start playing with a network emulator, and I'll show you the differences when you have a network emulator enabled with certain levels of latency on the network, and I'll show you how that affects the FTP transfer and how FileCatalyst is not affected, and then I'll introduce some packet loss as well and show you how it further impacts the TCP transfers. I'm going to go into some considerations. Really, a lot of the software out there that does UDP-based acceleration, there's open source alternatives as well, Tsunami, UDT, and the same thing will apply. I'm just going to go into a few things you should consider, whether it be FileCatalyst or an alternative UDP-based solution, what you should look for, just to be sure you're getting what you think you're getting. And then I'll just briefly touch on some of the applications and solutions we built on top of the acceleration technology in the FileCatalyst. Again, this webinar is more to talk about the underlying benefit you get with acceleration, not about all the bells and whistles and features on top. You can get a lot of that from our website, but I'll touch on them at the end, and then I'll answer some questions. So hopefully we'll keep it short. I'm hoping my presentation will last 10-15 minutes tops, and then we'll get 5-10 minutes of questions, and we'll get you guys back on your way. So to start with, the overview of TCP, as everybody knows, it's the foundation of the internet. Without TCP, the internet just wouldn't function. It has reliability and error checking, and it avoids congestion on the network. That's what it was designed to do. So if you were to overwhelm the internet with traffic, then you'd experience something called congestion collapse, and that's what TCP is basically designed to avoid. As soon as it experiences congestion, it'll rapidly drop back its rate to even out the flow of TCP with all other TCP streams on the network. And that allows you to share the bandwidth evenly with other applications. If you're on your internal LAN accessing the internet through a shared connection with the rest of your office, you don't want one computer to be overwhelming the network and everybody else's browsers can't reach a web page or can't send an email. You want everybody to kind of act fair together, and it's only possible because of TCP. So that TCP has congestion control built in. Again, it reacts very quickly, and it can reclaim bandwidth very quickly. And it works well for pretty much all internet traffic. It even works well for ad hoc file transfers or even large file transfers if it's point-to-point and you have the ability to tune the network on either side. It works great for that as well. So there's a few issues with it with regards to file transfers. A lot of the things that make it react quickly and avoid that congestion collapse that I mentioned also limit its ability to transfer fast when there's network latency or high bandwidth. So the flow control in TCP limits the amount of data that it can send without waiting for an acknowledgement. So when you get to a higher bandwidth, you can send that entire amount of window you're allowed to, and when you have latency involved in the network, you're sitting there waiting for a reply when you could be sending more data. So, and as you get geographically more distant, you're actually sitting waiting for data more than you're sending data, and you end up with a sort of a peak and valley effect if you were to look at the network graph, a lot of spikes. Of course, on a LAN, it's very smooth because there's no latency, so that instantly you're getting that acknowledgement back. But as you get, you're transferring from North America to Asia, where you have 250 milliseconds of latency, then that's where you're going to start really seeing the impact. The other problem with TCP for file transfer is, again, it's really aggressive in response to the network congestion. So what happens is anytime it sees a packet loss, it assumes that it's because of congestion. And this is fine maybe for terrestrial links, or if the end-to-end link is all terrestrial. However, there's reasons why there's packet loss other than congestion. For example, you're on a wireless router, or you're connecting over a cellular modem, 3G stick or 4G stick plugged in a laptop, or if you're dealing with satellite connections, then interference can actually happen from a cloud going by, or you go from room to room, there's walls in the way, and so TCP is going to give you less than optimal performance on those types of networks as well. And that can happen even within an office, not just across the world. So all this, combined, it kind of limits the ability of TCP when you get to a higher bandwidth to transfer files at top speeds. And again, I mentioned a bit earlier that you can actually tune it a bit, but you need access to changing registry settings and that sort of thing on the OS on both ends. So both ends have to have it. So when you get into a many-to-one, if you're in an organization where you have a lot of people sending into your central location, it might not be feasible for you to change your location settings and then go tune TCP on every desktop. And what if someone new calls up and says, oh, we need to send you a file? It's not going to be easy to say, well, open up regedit and go in and tweak your settings. It's just not going to happen. So that's why it's just not really meant for bulk file transfer, especially at today's bandwidths. And as we know, bandwidth is getting cheaper, so the problem is just going to get larger and larger. So the alternative transport on the internet is UDP, and a lot of you probably know UDP isn't typically reliable. It can send packets at a nice fast speed, but it has no guarantees that the packets are actually going to arrive. It doesn't guarantee they're going to come in order. It doesn't take care of them being duplicated. So it has some nice properties, but you need more to the UDP to actually transfer files. You need some predictability, some reliability. So what FileCatalyst is, the underlying protocol it's a UDP, but we've built our own application level protocol on top of it to control how fast we send, to control retransmission of any packets that are lost, to control how we detect congestion on the network. So we can, just like TCP, play fair with other network, but we make it tunable so that you can react quickly to the congestion on the network and slow down rapidly, or you can slow down a little bit, let that traffic through, but not really impact the overall transfer speeds. We have the ability in FileCatalyst, again at the application layer, to instantly detect your link capacity. So we do a little negotiation right at the beginning of any file transfer, and we can tell that you have a 10 megabit link or a 45 megabit link or a 100 meg link. And I'll give you a little bit of demonstration on that later. But the real nuts and bolts underneath is that where TCP, if I go to the previous slide, I didn't really go into the diagram. TCP is very serial and it's single threaded. You're going to send one packet of data or a block of data across to the destination. It's going to reply and say, I got it. You send the next one. So if I go to the FileCatalyst approach, you're actually sending multiple of these in parallel. So you're actually going to have one that's waiting to be acknowledged, but while you're waiting for that acknowledgement, you're sending the next one. And you can tune the size of those packets of data going across much larger than you could with the TCP window, and you can tune how many of those are going to be in transit at any one time. So what you end up with is you can tune how much in-flight data there will always be at any one time with FileCatalyst. And it translates into the ability to saturate pretty much any link speed at any RTT level. Wow, that's unexpected. Yeah, the graphics on the right-hand side aren't popping up properly. So we'll just ignore that column. The FTP throughput, you can see here I have an example here, 45 megabit link, and you can see North America to North America with an RTT 40 to 60 milliseconds. The FTP throughput is only 6 megabits, whereas the FileCatalyst throughput is pretty much a perfect theoretical limit, 44.3 out of a possible 45 megabits. Now you have North America to Europe and North America to Asia, where you have increasing RTT values, and you can see the FTP throughput goes from 6 megabits down to 1 megabit down to 700 kilobits, whereas the FileCatalyst throughput is the same no matter what. So I'm going to quickly go into a demo of FileCatalyst. Let me bring up, first of all, I'm going to show you I have an ongoing ping that's running, so I have no latency on the network. Connecting to a local machine, but I'm going through a network emulator called a Linktree. So let me just bring that up and show you. So this Linktree interface, essentially, it lets me emulate different varying degrees of latency and packet loss on the network. I can set it to be a 45 meg link or 100 meg. For this demo, I'm going to show a 100 meg link. Okay. So I'm going to bring up FileZilla. I think it's something that most people are familiar with for sending files. And I'm going to connect to the network on the other side. I have a 300 meg or roughly 300 meg file, and I'm just going to drag it over. So you can see it's going fairly smoothly. I'll just show you on the Linktree what it sees is going through. So I'm getting pretty much a perfect 100 megabits on the network when I have zero latency going across. Okay. It's actually popping up to about 5 milliseconds while the transfer is ongoing, but it'll drop back down. Okay, so it's taking about 25-30 seconds to 26 seconds to finish. Okay, so just to compare apples to apples, I'm going to transfer a file with FileCatalyst to the same site. Let me just go back to that same location. There's 300 meg file, and I'll drag it over as well, just overwrite the same thing, and we'll go back and we'll just compare the amount of bandwidth that's being consumed by the FTP client on a clean network to the amount of bandwidth being consumed by FileCatalyst on the same clean network. As you can see, they're both pretty much maximizing the network. They're getting the full 100 megabits on the LAN. So I'll let that complete. Okay, it's all done. So now what I'm going to do is I'm going to emulate 60 milliseconds of latency on the network. And that's typical of what you'd see maybe from a coast-to-coast, New York to LA type scenario. So I'll put 30 seconds in one direction, and 30 milliseconds rather, and 30 milliseconds in the reverse direction. And I'm going to rerun the transfers. So let me go back to FileZilla, and I'm going to upload the same file. And now let's take a look how that 30 milliseconds in each direction, so a total of 60 milliseconds, impacts the bandwidth of the FileZilla transfer. So immediately, as you can see, it's not able to achieve the speeds that it was in the previous transfer. It looks like it's getting, well actually if you look here, it's getting about 32.7 megabits per second of a possible 100. And that's with 60 milliseconds of latency. Okay, so this is going to take a few minutes, 50 seconds. Let's just assume that it's going to stay the same throughout the transfer. So I'm going to go back to FileCatalyst now, and I'm going to do the same file transfer, yes, and start it up, and we'll go see how that 60 milliseconds of latency impacts the FileCatalyst transfer. So you can see it's pretty much has no effect whatsoever. FileCatalyst is still getting the full 100 megabits. So yeah, big deal. New York to LA, 60 milliseconds. You know, it's dropping down FileZilla, so maybe I'll just transfer 2-3 files at once and I'll still get my 100 megabits. Okay, well, maybe that's okay in North America. Let's up the latency to something you might see to Asia. So let me put this to, I don't know, 110 in each direction. Apply the changes. Now let's see how FileZilla fares. Okay, let's go back and take a look. So now you can see it's even lower than it was before. Now we're talking, getting 8-9 megabits out of a possible 100. Now keep in mind, I haven't introduced any packet loss at this point. It's only latency that I've introduced. So I'm going to, why don't I go and introduce some packet loss. Let's give 0.1 packet loss in each direction. Apply this. We'll do this mid-transfer and see how it affects the FileZilla transfer. So you can see the transfer is actually slowing down even more. Now you're down to looking at a transfer that's 3 to 4 megabits. Actually, it's dropping down below 2 megabits, 1.5 megabits, almost down to 1 megabit now. Well, it's below. It's actually below 1. So it's hovering around 1 megabit of a possible 100 megabits now. It's kind of fluctuating a bit, actually. So you can see definitely there's a dramatic effect with 0.1. And by the way, the internet average of packet loss is 0.5. How much that affects any TCP-based transfers. Now, I mean, I'll reconfirm that this is a completely untuned OS, and I'm just using FileZilla out of the box. I could probably go and tune the registry on both sides. The server I'm sending to is also Windows to get a little bit better speeds, but this is typical of what you could expect if you had a 100 meg link and you're trying to send a file to Asia with FileZilla. In fact, I just saw connection closed by server, so FileZilla is probably going to have to reconnect. So I'm going to stop this, and now let's go back to FileCatalyst and do the transfer there and see how it's affected by these same conditions. Now let's go back to our apposite netropy interface, and here we go. We can see the transfers taking place, and once again, it's not affected in the slightest by these conditions. So we're getting a full 100 megabits. Now I could go on and continue to up it, and I could do higher rates, but I think you get the picture. FileCatalyst is not, the underlying transport's not affected in the slightest by the latency and the packet loss, whereas FTP is dramatically impacted. So I'm going to go back into my slideshow. So some considerations you want to pay attention to if you're looking at FileCatalyst or, again, any other UDP-based file transfers. You want to make sure it plays fair with other traffic on the network. So there's solutions out there that are great at, you can tell it to send at 100 megabits, but what happens if someone starts another transfer in the meantime? FileCatalyst will automatically throttle back and allow that traffic to go through, and then it will speed up again. FileCatalyst is also able to transfer a file at 10 gigabits per second with a single stream. So I don't have this machine set up for 10 gigabits, but we do have other webinars where we did show 10 gigabits and compared very similar to what I'm showing now to FileZilla, and we show you what happens. But we're one of the few vendors in the world able to actually reach the 10 gigabit speed with 200-300 milliseconds of latency and packet loss with a single stream. Other vendors will try to break up a file, send multiple frames of a video file concurrently to reach the same speeds as FileCatalyst. Another thing is how does the system perform with many small files? So a lot of systems like FTP will have setup and teardown commands for each file that goes across the network. So if you have high latency and you take 3 commands to set up a transfer, and you might be looking at a full second of downtime while you're just sending the commands to start each file, and let's say you have 10,000 files or 100,000 files, you got a lot of dead air. So you want a solution that can actually maximize your bandwidth regardless of the size of the files. Now if you look at our June webinar, I actually went into a demonstration of how FileCatalyst approaches that problem, which is by essentially creating a giant tar of your smaller files and transferring it as the tar file is being created, so we're still able to maximize the link. You want to make sure that the solution doesn't just break up your file and send UDP. You want to have security and reliability and automatic resume in there. So other solutions with UDP, seeing it's not reliable, may end up, if you lost the connection, you might have a file on the other end that has little pieces missing inside of it. So you want to make sure that if you lose a connection and you have to reconnect, you're able to retry and resume the file that was broken. You don't want to lose potentially several hours of transferring and have to start from scratch. And you want to make sure it's all encrypted with AES encryption, which is pretty much industry standard. And then not only what what kind of transport it has, but what sort of tools are built on top. FileCatalyst has a whole suite of applications. I'm not getting into them much. You saw what we call our Express application a minute ago, which is sort of our basic FileZilla or FTP client replacement. But you want some automation tools in there like watch folders, which again we have. It's our FileCatalyst hot folder. You want an SDK so you can take an API and embed it into your existing application. Or maybe you want REST services so you can create a web application or control it from an existing panel and maybe replace your existing back-end transfers with the UDP-based process. And then something that has central management. If you're an enterprise and you have software deployed to hundreds of locations, it might not be feasible for you to remote desktop into each one or contact them and get them to open firewall holes so you can connect in. You want a tool that's central that you can set up with each of your end nodes to connect back into, so you don't need to worry about firewalls, but you can it can tunnel back and you can do configurations, you can manage it all from one central web portal. And just a little bit about what we do, who we work with. We actually deal with customers from all verticals. So one of our biggest areas is media and entertainment, but enterprise IT is big for us, military, government. We have support and we have customers currently running in pretty much all cloud types of deployment like Amazon or Azure. We are a technology provider, so we do provide a ton of integration options. So anybody who sees that type of a transfer and wants to integrate it into an existing application, we do provide a partner program for that, and we have an integration support team that can actually work with you to do the integration. We have APIs in Java, C++, .NET. We have Android and iPhone APIs as well. Another thing I wanted to point out is that we were found by an independent study to be the only solution to maintain 10 gigabits with very high latency and packet loss. So, and that link is on our website as well. And yeah, just for more information, you can go to our website. We have a ton of tutorials. If you go through our webinar section, we have a lot more webinars that describe a lot of the advanced features. And you can always keep up with us on FileCatalyst Twitter, Facebook, LinkedIn, Google+. And that's pretty much it. It was short and sweet, but I think it got the point across. So if anybody has some questions they want to type in now, they can go ahead, and I'll try and answer them. And I don't have any questions coming in, surprisingly. Okay, I'll give a few more minutes for questions, but if there is none, then yeah, this will be a nice short 15-minute session. Okay, so I got a question coming in. What about normal connection, say 10 megabits? So I can show you. Let me go back to the network emulator, and I'll set it to 10 megabits just to give you an idea. So where are we here? So I'll set this down to 10. You certainly have to have, with 10 megabits, you certainly, if you're within the city or like a very close region, it's not as big of a deal as it is going to, say, Asia, but there still is an impact. Let me put this back to, let's say you're going across the country again, so let me put it to 35, let's say 75 milliseconds. Apply. Okay, so minimize that. Let me escape out of here. Bring back our FileZilla. Let's see how FileZilla does on a 10 meg connection with that latency. I'm going to close this up. Yeah, so it's getting pretty close with across the country latency with 10 megabits. And it's not perfect, it's up and down a bit. So let's bump it, let's say that there's, like I said, the internet average for packet loss is actually 0.5, so let's point it to 0.2 and see what happens. You're getting a lot of, peaks and valleys, and it's not terrible, put it that way. although now it's looking like it's getting a little bit less stable. Let's see how it's, yeah, so it's really dropping down. So 7 times 8, you're getting like 5-6 megabits with 0.2, which I'd say this is pretty realistic, the numbers I set up for just across the country, across the US. Stop and remove. And now where'd my FileCatalyst go? Oops. Go back in here. So let's see if FileCatalyst does just as well with the lower speed link. And go back and check what we're getting. So here's your FileCatalyst transfer going across at the 10 megabits. And you can see it pretty much instantly increased speed to 10 megabits automatically, and it's getting you pretty much full speed with those network conditions. So yeah, I mean, and I had a conversation with someone this morning about the 10 megabits or what's realistic. I mean, what's realistic now, you know, take a look at the way bandwidths are increasing. Your typical ISP is now offering 60, 80 megabits downstream to your house. You know, within a year you could be looking at 100 symmetric. So 10 megabits is realistic maybe now, or maybe even for some people that was what they had a few years ago. I mean, so yeah, if you're looking at business class internet, it's coming down in price. So you're already at the boilover point, you know, around 10 megabits when you're going across the country. If you start to increase that to 50 megabits, you're not going to get much faster with FTP, but FileCatalyst or any accelerated UDP solution is going to kind of get whatever line speed you have, so you don't even need to worry about it in the future. Okay, so any other questions? Anyone? Okay, well, I'll give another 30 seconds for someone to ask a question, and then I'll just wrap it up. Okay, well, thanks everybody for attending. Short, but hopefully informative. And okay, got another question, last second. Do you need a client? Absolutely. So our client software is what I just showed you. So I'm showing you kind of a minimal interface of it, but there's a server on the other end that both FileZilla and our client application is connecting to. So this is the client. So a typical deployment, you'd put FileCatalyst server, which is essentially like a replacement for an FTP server, on your central location, and you deploy the client software to your other locations that need to send files up into and pull files out of the FileCatalyst server. And then we have several flavors of client software. So this is one of them. This is the Express. I'm actually accessing it through our hot folder. We also have our hot folder full interface, which is, it has a scheduler, so you can define various sites, various hot folders, and then you can schedule uploads and downloads between any of the sites in the folders. Lots of bandwidth scheduling on top of that. We also have web plugins that you can put into a web page, so you could have your users come browse into a web page. It loads up our applet inside the web page, and they're automatically configured to upload at full speed to your server. And that can be integrated with a web portal. And we have command line tools, and as I mentioned, we have APIs in Java, C++, iPhone, and Android. So we have many different flavors of client applications to send files with, and then we have the server application that acts as kind of the back end. Okay. All right. Anything else? I think we're pushing over the half an hour right now. So. Okay, thanks a lot, guys, and hopefully you'll join us again next month. If you're on our newsletter, then we always keep you up to date on what's coming next month, and you can always check out our archived webinars as well for even more information. Okay, thank you very much, and have a great day.